here for the second part of the first lesson. And if you can think back to your, I guess, pre-algebra or algebra class, definitely algebra, I think you would have used this. You should recognize this thing. It should look pretty familiar to you. And I made a mistake from the last video. It should be applicable to this. Definitely right triangle. And it basically states a squared plus b squared is equal to c squared. This is the Pythagorean theorem, right? And we're going to see a direct application of it here in a second. So it's called the distance formula. And the distance formula is the way to calculate the distance between any 2 points on the coordinate plane. Again, this quote-unquote should be review. I don't know how much background some of you have in algebra. So in this distance formula, we have our point here. It has an x and a y value. We have another point up here. It has an x and a y value. We want to find the distance between those two. And one way to do it is to plug those numbers into this distance formula here. Totally valid. If you like formulas, if you want to plug them in, go for it. There is a bit of an easier way to do it. Can I talk about it? I don't think I do. Okay. Let me see. Yeah. So you can use the distance formula. I would personally use the Pythagorean theorem. Note here that this distance formula is essentially the Pythagorean theorem, right? We have the distance between the x's, right? So the change in x's here is this distance, say, is a, and we take that distance, the difference, we do a squared. We're going to add the distance of between the y's, so that's the distance there, plus b squared, and then we square root the whole thing in order to get what? In order to get c, right? So c squared is equal to a squared plus b squared. This is the method I would use. I would essentially just say, okay, well, I want to take the square root of a squared plus b squared. And I would simply, instead of subtracting x1 from x2, I would just count across. Either way, whatever works easiest for you. We'll try it both ways. So here's our first example. Determine whether or not the given segments have the same length, justify our answer. So basically we need to find the length of all of them. The first one it talks about here is AB and CD. So we go up, we find AB and CD, AB and CD. So we need to find the length of both. The way, again, the book likes the distance formula and we'll use it for everything. So I'm trying to get this down. Okay. So we have A to B. If we wanted to use the distance formula to find the length of AB, we need the difference of the x's, I think they do first. So the x values here. This one has an x value of 1, and this one has an x value of -4. So what is 1 minus -4? Well, 1 minus -4 is 5. So they basically plug this in. Of note here, when using the distance formula, it says x2 minus x1, and then it has y2 minus y1. Totally okay to switch them around. It's also totally okay to switch around the x's, but not the y's. As it turns out, it doesn't matter what x2 and x1 are. When you subtract them from each other, you're getting the difference, right? So the distance between them. I'll show you a quick example here. We did the 4 and -1, or 1 and -4, right? Or the values earlier. So I'll show you what happens. If we do 4 minus -1, that equals what? 4 minus -1 is 4 plus 1, or 5, right? And then if we do it the other way around, if we do -1 minus 4, -1 minus 4, that's equal to, it's going to be a different thing here. -1 minus 4 is -5, right? So you'd think, oh, well, they're different values. But the trick is we're squaring it. What is 5 squared? 25. What is negative 5 squared? Negative 5 times negative 5 is equal to 25. So that negative will always disappear when we square it. So because we're squaring it, you could do x1 minus x2 or x2 minus x1. Doesn't matter. Just subtract the two x values to find a, essentially. Cool. So that's what we did here. We found 5, whoops. X minus x is equal to 5. And then we can subtract the y's. The y values for a and b. The y value for b is 2. The y value for a is 4. So therefore, 2 minus 4. Again, 4 minus 2 gives you the exact same value here. It'll end up with negative 2 squared or 4, 2 squared. It's the same thing. It's going to be 4. So what is 25 plus 4? It's 29. So then the length is the square root of 29. And we can just leave it like this. We don't have to get some fancy decimal. If you want to put a fancy decimal, I will accept fancy decimals. But know that this is technically kind of the more correct answer because it's more precise. We do the same thing for CD. For CD, though, I'm going to do it, quote unquote, my way. So if I were to find the length of CD, I would simply, and I find it helps to just draw a little right triangle. See, we're on graph paper, so right triangles are easy. I'm not even going to bother putting, well, okay, fine. See, it's a right triangle. So in this case, I can label it if I want. I can say a and b and a squared plus b squared equals c squared. If I say a squared plus b squared equals c squared enough times, maybe it'll help you remember that the Pythagorean theorem is a squared plus b squared equals c squared. So let's say this side is a. So that is, let me count here. 1, 2. So that's 2. Oops. Because it's a squared plus b squared equals c squared. So 2 squared plus, and then let's find this one. 1, 2, 3, 4, 5. So that's 5. And then we'll square it is equal to c squared. So therefore, 2 squared is 4. 5 squared is 25. Is equal to c squared. Or 29 equals c squared. Or c equals the square root of 29. Note here that c refers to this side, right? This is side A, this is side B, this is side C. Don't get confused by the point names. So the length of side C, or segment CD, right? Whatever, I'm not going to relabel it. But note here that it's CD. Side CD is equal to the square root of 29. Therefore, they're equal. Cool. We'll do another one just for fun. This one is EF and GH. EF. Go ahead and see if you can fill in these blanks. So I'm going to do a quick little pause here. Usually I'd pick something that's around the house and see if you can identify it while I put it over the screen, while you pause and try and fill in the blanks. So pause. Okay, so I'll go ahead and erase these things. We don't have to walk through every single one of these. You guys can, I'm just giving you the answers. Of note here, if you find an error in the book, I will happily give you some extra credit. So keep that in mind. So the square root of 26 is not equal to the square root of 32. So therefore, they're not the same length. Cool. I showed you the counting method. I'm not going to go through that one again. But I find that that counting method is much easier than using a formula with a bunch of moving parts. I feel that if I wanted to find this length, I'll go through the steps again. I can label it A, B. C is always the hypotenuse. And it's the weird one because the formula says a squared plus b squared equals c squared. C is all by itself over here, right? The hypotenuse squared is equal to the other two squared. So I can count a, 1, 2, 3, 4, 5, 6. 6 squared, no subtraction necessary. Yeah, sorry. Yeah, okay. So this is a B, not a 6. So side B here, 1, 2, 3, 4, 5. So that's 5 units. So 6 squared plus 5 squared equals c squared. That's 36 plus 25 equals c squared, where c equals the square root of the sum of those two, which is 61. Cool. Note here, I make a ton of mistakes, and you don't get extra credit for catching my mistakes. And my wife just laughed at me. Okay, go ahead and try this problem. I'll pause here. So pause here, see if you can solve for this one. Ooh, it's a book. Okay, same sort of deal here, basically just finding the length of two different segments, proving that they're equal to each other. Both come out to the square root of 13. So therefore they're equal, they're the same length. Okay, last little formula thing you need to know is the midpoint. The midpoint of any sector is the point that is directly between the two endpoints. Of note here, any line that goes through the midpoint is called a segment bisector because it's bisecting that that segment. So it's going through here in the middle. Traditionally, the middle of segments is called M unless there's another reason not to, or there's other midpoints. So here it says that PM is equal to MQ. Also in geometry, you'll find that we need to show that parts are equal to each other in length. And so we'll do that using these little tick marks. So this is a little tick mark, which essentially means that this segment here, PM, is the same length as this segment here, MQ. So those two segments are the same length, therefore M is the midpoint. And we have some formula to go with this. It looks big and complicated. It's really not. Let me break it down for you. It's the midpoint formula. But the midpoint formula is when you have a segment in the coordinate plane, right? You have point A, point B, and a segment in there, and you want to find the point right in the middle. What are the coordinates of that point? And remember, there are two parts to any point's coordinates, right? It always goes x, we put a little comma, and then we put y, right? Here's the x value, here's the y value. Same deal for m. There's going to be two parts, and we're going to treat them totally separately. The first one here, I'll use x as an example. This is the formula, right? It's also printed here. It says x1 plus x2. Does order matter there? Can I do x2 plus x1? Is that the same thing? Yes, because addition doesn't matter what order you add things in. So I add the two x's together, and then I divide by 2. So I'm taking two things, I'm taking some things, adding them together, and then I'm dividing by the number of things I added together. What's that called? Well, it's called the average, right? That's how I remember this midpoint formula, is the new x value, so the x value of point M here, the midpoint, is simply the average of the two x's. So I can do averages pretty fast in my head. If the one x value is 1, the other x value is, wife, give me a number.
What?
Give me a whole integer.
5.
5. Okay, the midpoint of 1 and 5 is 3, because 3 is the average of 1 and 5, right? I can add them together. I can say, ooh, 6, and then I divide that by 2, and that gives me 3. Give me two more integers.
17 and 3.
Okay, cool. So 17 and 3, those also I can simply add together and then divide by 2. And so I know that the midpoint of those two guys is 10. So if 17 and 3 were my y values, I can simply average them out. If you don't feel like using an average and you really want to flip back here in your book and use this midpoint formula over and over again, feel free. It's totally within your power. But you may want to mark or note this page in your book so you can flip back to this and refer to it. At some point, you may be called upon to have these memorized. So plan ahead. Here's an example. It says there's no picture with this one, so we just have to visualize it. An alternative, if you're having trouble visualizing or get really confused, you can always graph these sorts of things. It says if segment RS, right, it's a segment, it's not a line here, it's a segment because it doesn't have little arrow marks. If segment RS has endpoints R, which has this x and y value, and S, which has this x and y value, then the midpoint M of segment RS lies on the x-axis. So I think we're supposed to prove if this is true or not, right? So we essentially use the midpoint formula to find the midpoint of RS, and then see if that lies on the y-axis. So again, I'll do one more pause here. Let's see if you guys can figure this one out. Here. Pause. Okay. So hopefully you got the midpoint being coordinates at 0, 2. Is 0, 2 on the y-axis? Yes, the x-coordinate is 0, therefore it's on the y-axis. If we were to graph this out, boop, boop, in my fancy graph, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, Bear with me. Look how quick this is. R is at 3, 5. 1, 2, 3. Oops. Here's R. S is at -3, -1. We'll see if this works. And then there's a nice perfectly straight line between the two. And the midpoint is at 0, 2. Yeah, that checks out. Ballpark, pretty close. Obviously, if you use actual graph paper and a ruler, it should get much closer. But we can do a little graph to kind of use this as a guess and check. Is this on the y-axis? Yes, this is on the y-axis. Okay, 2 more here. Another pause. Pause. It's an Archie comic. Okay.
I'm not supposed to tell them.
They knew.
They have to guess. Don't deprive them.
Okay, cool. 2 more endpoints. Essentially, what is the average of 6 and -6? 0. What is the average of -3 and 3? 0. So that's our midpoint there, 0, 0. Average of 7 and -5, 1. Average of 0 and -4 and -2. To me, I often think of these just on a number line, and then I think of the point just in between. So when we're on a coordinate plane, like these ones here that are on a coordinate plane, we can kind of imagine just squishing this down flat or squishing it just vertically, and then just dealing with each dimension one at a time. And we'll do this later on too with other things. So it says here AB has the endpoints 6, -3, and -6, 3. So I could just think about a number line for these x values, right? Here's my number line. Here's, say, 0. That means that's -1, 2, 3, 4, 5, 6. This is positive 1, 2, 3, 4, 5, 6. What value is directly in between -6 and +6? Well, it's 0. Let's try some other ones. We did. How about 7 and -5? Right. This was so straight. So it's 1, 2, 3, 4, 5, 6, 7. So 7 is right here. This is the x value for j. I'll go ahead and label this. So that's j. I can do the x value for k, which is at -5. 1, 2, 3, 4, 5. You know, number lines are just like one-dimensional graphs, right? And that one's labeled as k. So what's the midpoint of kj here? It's essentially what point is directly in between k and j. It becomes pretty obvious that it's 1. Even my terrible graph here, it just pops right out. It's right in the middle. So that's how I often visualize these. But you can run through the average formula, which is the midpoint formula, add them, and then divide by 2. That's cool. All right, that's all I got for you guys. Good luck.